Today is the 7th of August 2023. Okay, and I would like to introduce you to the topic mean and range as in statistics. Okay, before I start the lesson, thank you to everyone who has been watching our videos. It's been very, very encouraging. Okay, depending on which platform you are watching from, please subscribe, share, like, follow, etc. Okay, it will be very much appreciated. Thank you so much. I normally write in the comment section, please follow my notes / scripts. These are my notes. I write them, I go through several times before I share them with you. Okay, please, assuming for instance, I want to say 2 degrees. Okay, and I say 2, please follow what I'm pointing to at that minute. Assuming I wanted to say 2% and it comes out as 2 pounds. If I'm pointing to 2%, and that is what is on the script, please follow that. Okay. Thank you very much. Now, beware of scammers. I wouldn't come and contact anybody asking for money to donate to an orphanage or something. So if somebody comes to you asking for money to go and help some orphans or orphanage somewhere, it's not me. Or if somebody comes to you and say that you've watched the video, so you need to give this X amount, please, it's not us, it's not coming from me. Okay, the videos are available, all of them on YouTube. Just watch them and help yourself. Okay, if you have an exam to write next year, just learn as much as you can and go and just get what you need to get. We are not asking you for money. So if somebody does that, report them. Thank you very much. So far, I'll recap. We've done a lot of algebra work, okay, and then I introduced you to pie charts. I did some interpretation of pie chart with you, and I solved a full question of pie chart with you. We went on to do substitution, and then we got I did simple things like y equals x plus 2. This is a 2, okay, and then if x is 6, what is y? We substitute x, and then it's 6 plus 2, which is 8. Okay, that will be our y. And I said this is a preparation to do some graph work. When we're doing algebra, when we got to this point, we had to stop. Okay, but here, if you've given one variable, then you can find the other variable, and that's what the graph work is. You might given a set of x values to find the corresponding y value. So with that, you can draw a table, do that, plot your graph, and use it to answer the questions that will follow. Okay, now data can be non-numerical and numerical. data, I mean collection of values. Okay, now with the numerical one, it can be continuous, where you can measure. Okay, so like how much? So maybe 675 kilometers, 14.56 kilograms of rice, flour, the weight of a fish, the weight of something a truck is carrying. Okay, and then we can have the discrete, the one you can count. Okay, the continuous one, it can be round, triangles, circular. Okay, you can count how much of those. Okay, how many. Okay, now the discrete one is like 3 bags of apples, 40 cakes, 52 cars. Okay, 300 houses. Okay, so these are the differences that you can get in data. Okay, now with the what we are going to do, we'll be doing a lot of work using numerical values. Okay, now let's consider some definitions. Today we'll look at the range and the mean. Okay, and then tomorrow the range and the mean, and then tomorrow we'll look at the median and the mode. Because if you are going to do these graphs, we'll be asked at times to find them. So I want to show you what it means and how to find them and how to interpret them. Okay, so what is range? Is the data is spread across a distribution. So if you have like 10 set of data or 20, then you look at the highest value and you look at the lowest value and you find the difference. That is basically your range. So to make it simple for you to understand, okay, I have these examples. Okay, normally you get more than 4 sets of data. The more the data, the accurate your results. So you can, if you end up getting 5 sets of data, okay, over a period, 50 set of data over a period. Normally, if you have 4 sets of data, it doesn't really show anything. Okay, it is there like that. Okay, because you might have outliers. Okay, so you can use this to interpret what has just happened in a short span. But if you want to look at a longer term, this might not show this kind of data, 4 set of data, and like this. These are also, they are too small to make a decision on. You need to look a bit further, maybe take a data over a month, over daily, over a month. Okay, because the more data you have, the more accurate you can get. You can't always be 100% accurate, but more is better than less. Okay, now if you have this, okay, the range is simply the highest value minus the smallest value. So the highest value here is a 0.18, this one. Okay, the lowest is 0.15. Okay, I've arranged them from the lowest to the highest. Normally they will mix it up, so you might have to find them. Okay, so the range here is 0.18 minus 0.15, which is 0.03, which is quite a small range. Okay, now when the range is small, it just tells you that the values are similar in size. Okay, so for instance 0.03, between 0.18 and 0.15, there is no much difference. Some of the data, the range can be 0.0003. Okay, so that is, they are very close together. Now, large range implies widely values in size. Okay, so the values are widely spread. Okay, so now the example I have here is 40, 75, 120, and 180. Here again, your highest is 180 and your lowest is 40. Okay, so 180 minus 40 is 140. So here again, your data 140, your range 140, shows that it is somehow widely spread. Okay, unlike here where it is just 0.03, which means that they are very similar. Okay, so with this behind your mind, let's quickly look at today's what I want to show you today. Here is a sale in shop 1 and shop 2 for last week. Okay, so shop 1, these are the sale amount, 72,000 all in pounds, 75,000, 92,000, 80,000, 95,000, 98,000, 642, 87,685. Now, with shop 2, you have 8,000, 26,000, 21,500, 101,000, 31,700, 6,000, 46,700. So to find the range, shop 1, the highest if you scan is like 96,642 there, and the lowest if you scan again is 72,000 here. Okay, so to find the range, this is the word I'm using, range. Okay, it's 98,000, the highest sale value, and the lowest sale value for the week. Okay, now if you subtract using a calculator, you have 26,642, which is 26,642 in pounds. So if you look at shop 1, their sale is a bit close together, even though they have a bigger range. But look at shop 1. Okay, I mean this is shop 1. But look at shop 2. If you even look at the table, there is 8,000, there is 6,000. Okay, and then they have 101,000. Okay, so if you look at the range, this 101,000 minus 6,000 will give you a difference of £95,000. That is the range. So straight away, with analysis, there is something wrong, because what did they do on this particular day to get this bumper sale, and what happened on this day to get 6,000? Maybe did it rain? Okay, so there should be questions asked, because you want to get sale as close as £101,000. £101,000 here is an extreme value that, or in maths we call it an outlier. It's an outlier sale where the sales are not, you have sales like 26,000, okay, and then you have this high sale in a week, okay. So the shop owners should be looking at what they can do to match this sale every day. Otherwise, they are going to get out of business, because they have workers coming in every day that they have to pay for. So if on a particular day you are doing this might not even be enough to pay your workers, let alone pay for the premises and the other things you are using, like electricity and stuff. So if they have to see what they are doing on they did this day, so that they can generate more sale closer to this amount. Okay, I hope I'm making a bit sense. Now, shop 1, the range is 26,642. Shop 2's range, we have an outlier of 101,000 and a very low sale on one of the days of 6,000. So the range here is 95,000. Okay, so look at shop 1's range and look at shop 2's range. So this one just tells us the values are so wide apart. This one tells us they are not too wide apart. Okay, there can be still room for improvement, but with this kind of range, this is better for shop 1 than shop 2. So shop 1 sale is consistently better than shop 2, because if you even look at the table, you can clearly see that. Okay, and shop 2 has an outlier sale of 101,000. Okay, so normally if I'm going to consider the range, at times it's better to leave out the outlier if you are doing a graph work. Okay, but I'll show you when we get there. Now let's look at the mean. Okay, the mean of this sale for shop 1 and shop 2. Okay, the mean simply means if you have 8 sets of data, you add all the data together and divide by 8. Okay, so it's commonly used like an average. So the total sum of values, okay, here the total amount of sale over the week and the number of values. So we have 1, 2, 3, 4, 5, 6, 7, Okay, 7 days. So we are going to add all the sales together and divide each by 7. So with shop 1, we have 72,000, all in pounds, as in money, okay, not in weight, pounds as in money. 75,000, 92,000, 80,000, 95,000, 98,642, 87,685, all divided by 7. Again, if you add all this money in on the calculator and divide by 7, you will get 85,761. Okay, that is how much you get. But look at the total amount for the week: 600,327. Now for shop 2, if you add everything together, all the sale they did: 8,000, 26,000, 21,500, 101,000, 31,700, 6,000, 46,700. Divide by 7, you will have 240,900. Divide by 7 on the calculator, you have 34,414.29 to 2 decimal places. Now, if you want to make a very accurate decision for shop 2, you might have to remove the outlier and divide by 6. Okay, because this is a one-off. Okay, so if the shop wants to help itself, they will have to think, what are we doing on this? Did we do this day that went so right to get 101,000? And what did we do on this day that went so wrong that we just got 6,000? Okay, there can be so many reasons. Maybe it rained heavily, maybe there was snow, maybe people couldn't have access to the building early. It can be so many things, because on that same day, shop 1 made a sale of 98,642 pounds, which was the highest for the week for shop 1. So was there a blockage to shop 2 that diverted all their customers to shop 1? We don't know. They have to find out. Okay, so that might be something they have to look into. Okay, now, so we've seen the mean sale. So we've seen how to calculate the mean, and we've seen how to calculate the range. Okay, so when you have an outlier like this, at times using it to calculate won't give you a true reflection. So here, shop 1 on average took home a sale of 85,761. But look at shop 2, 34,414. But assuming we made the decision without this figure, they would also have taken much less. So they need to have a good think to see how they can improve their sale. Okay, so when extreme sale value is removed, mean will be much less. Okay, so what the shop owners have to do is, maybe they are in a corner somewhere, or maybe there keeps from coming obstructions, or maybe customers can't get to them, or maybe shop one has easy access, maybe lifts and other things. So they might have to try and think hard and see what they can do to improve their sales, so that at least it can match this figure. Because if they can do this on a particular day, that means they are capable of doing it every day. But why is it that they just did it one day in the week? Okay, so this is what I have to share with you today. Tomorrow we might use the same table, or I'll bring a different table to show you how to find the median and the mode. Okay, we need to learn these so that we can use it to do some frequency table work and do some basic graph work. Okay, so thank you for watching today, and I'll see you next lesson.